Okay, we continue our class with ion and isoelectronic configuration. So here if you have aluminium, and this is the configuration for aluminium. So 1s2, 2s2, 2p6, 3s2, 3p1. Okay, and for 3 plus, which is in positive charge, 3 plus. So here this electron loss. So 2 and 1 ni hilang. Sebab 2 di sini tak ada. So ada 3 plus sini. 3 plus ni maksudnya you give 3 electron to others. Maksudnya aluminium ni lost its electron. And for isoelectronic is equal to different species having the same electron configuration. For example, here is oxygen. Oxygen is, if 2 minus, it will be here 1s2, 2s2, 2p6, F minus 1s2, 2s2, 2p6. And for neon, which is categorized as inert gas, so the configuration is 1s2, 2s2, 2p6. Means that for both three elements, it has same electron configuration. And for here is we call as partial orbital diagram and electron configuration for elements in period. So here the sodium, it has atomic number 11. And should be here is 1s2, 2s2, 2p6. So here this configuration is same just like neon before, and you just put 3s1 in the when you show the partial orbital, you just show 1. Here is you just show 2 electron here. Here is 3. So 3s2, 3p1. And is 3 is representing N, referring to shell. So how about argon? Argon is also considered as inert gas, argon. So here is 8. 2, 4, 6, 8. And electron configuration of chromium and copper. So here is 3d5, 4s1. First, you need to follow Afbau, then for and also for Hans rule, you need to fill out all the electron. Means that you need to distribute. Masih ingat lagi? Hans rule. Hans rule state that what? What is Hans rule? Tengok balik dekat Hans rule lah. Dekat Hans rule, dia cakap kamu mesti susun elektron tu supaya seimbang dulu, baru kamu boleh pairkan. Maksudnya kat sini, Kalau yang ni dia ikut Aufbau principle. Pauli Hans rule. State that when entering orbital of identical energy, electron initially occupied them singly and with the same spin that is parallel spin. So cara isi yang betul macam ni, kena penuhkan dulu, lepas tu yang dah cukup tu baru you pairkan. Okay, write the electronic configuration of sulfur 2 minus and nickel 2 and iron 3. Nickel 2 when it state 2 here and 3 here means that it consists of positive charge. Nickel is 2 plus, iron is 3 plus. So here is the atomic number for sulfur because when the atom gain electron, the charge will be negative. When the atom lost the electron, the charge will be positive. So in this case, it gain 2 electrons. So that's why you need to add 2. So the total is 18. So you need to write down the subshell. Based on Aufbau principle, you list down from the lowest energy to the highest one. So 1s2, 2s2, 2p6, 3s2, 3p6. And all should be total up to 18 electron. 6, 2, 8, 8, 14, 14, 15, 16, 17, 18. And for nickel is 28 electron. Here is positive charge. So means that it lost 2 electrons. So here you need to minus 2. So you get 26 electron. So you need to fill up all the number of electron to get 26 electron. Same goes for iron. And for this problem, ask you to write a set of quantum number for third electron and a set for the 8 electron of the fluorine atom. Use the orbital diagram to find the third and 8 electron. So for 9 fluorine, the third electron is in. Dia suruh kamu cari elektron yang ketiga tu terletak di right set of quantum number for the third. Terletak di mana? Terletak di mana? So the third electron tu terletak dekat shell number 2. Subshell dia S 2s dia letak kat sini. So its quantum numbers are, yang ni dia punya dekat subshell ni quantum numbers kita kena letak n equal to 2, L equal to 0 because here is S. Kalau S, simbol ni mesti 0. Yang ni magnetic quantum number equal to 0. Yang ni MS plus or minus half. Okay. The 8 electron is in 2p orbital. 1, 2, 3, 4, 5, 6, 7, 8. 2p. So the 8 electron is in a 2p orbital. So quantum number is n equal to 2. L equal to 1 because here is p, right? And M, L equal to negative 1. So in between negative 1, 0, positive 1 because here value is 1. So the value for magnetic quantum should be from around in the range of negative 1 to positive 1. Here is 0, so here also should be 0. And for MS is the orientation of the electron, means that up and down. So plus and minus, plus minus half. So give the full and condensed electron configuration, partial orbital diagram. showing valence electron and number of inner electron for the following element. So potassium, the atomic number is 19. So the full configuration is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. You need to total up to get 19. So 2 tambah 2, 4, 4 tambah 6, 10, 10 tambah 2, 12, 12 tambah 6, 18, tambah 1, 19. And for the condensed one, cut until here. So yang ni, part ni saja dia punya configuration sama dengan Argon. So ini kita bagi dalam bentuk condense. So yang selebihnya you kena tulis 4s1. And then dia minta partial orbital diagram. So lepas orbital 4s1 dia dapat 3D. Macam mana kamu nak tahu lepas 4s1 dia 3D ni? You kena tengok balik dekat akhbar principle. Ni yang ni. Ni lepas 4S dia dapat 3D. So you kena ingatlah configuration ni. Memang yang tu you kena hafal. Here is for molybdenum. MO is molybdenum. Same goes for previous one. Also for plumbum. And dimagnetism and paramagnetism. Paramagnetic substance, those that contain net unpaired spin and attracted by a magnet. And dimagnetic substance, those that do not contain net unpaired spin are slightly repelled by a magnet. And electron spin are pair or anti-parallel to each other. Dia mesti dalam bentuk pair. Kalau boleh buat dalam bentuk pair dan dia mesti berlawanan. And dimagnetism, kalau contohnya ni yang ampere, dia punya arah dia sama. Kalau ni paramagnetism, silap. Yang ni paramagnetism. Maksudnya arah dia sama. Kalau dimagnetism, dia elektron dia semua pair tapi dia punya arah elektron dia berlainan. Okay, use condensed electron. Kalau condensed, maksudnya yang ni kita panggil condense. Condensed electron configuration to write the formation of the each transition metal ion and predict whether the ion is paramagnetic or dimagnetic. So yang ni kamu dalam bentuk condensed, so plus 2 electron. Paramagnetic, dia sama arah. Paramagnetic sama arah, dimagnetic berlawanan arah. Okay.